Okay, students, we were in the process of revision of class 9 chapter, that is motion in a straight line. And in motion in a straight line, no doubt, one topic that is always very important: how to find displacement. And displacement is always a very important point to understand. So when we are talking about displacement, then displacement, always the definition will be final position minus initial position. So how to find in different cases, like motion in a straight line, like in the case of circular motion, or in oscillatory motions, or simple harmonic motion, like that. So let us try to revise this topic, displacement, in detail. Okay. So displacement, very important point to understand in class 9, and we have got this idea earlier also. So what is the meaning of displacement? Motion, chapter motion, displacement. Okay, the graph, and the true meaning of displacement is the change in the position of the object in a particular direction. We can say to find the distance traveled in a certain direction, or the difference between final position and initial position. So displacement of any object is given by the line joining initial position to final position of the object. Okay, displacement of an object we can find this. Or we can say it is the shortest distance. Displacement is the shortest path between initial position and final position of the object. How to find displacement? In any case, maybe take one example. If any person has started from the point O, motion has been started. He first went to point H, maybe in east direction, and then he moved to point maybe G in north direction. So if we have to find the displacement of this object, maybe the t is equal to 0, initial time it was 0, and after some time t is equal to t, the object reaches at point G. Then according to this definition of displacement, initial position, this is initial position. And this is final position. So you join the line, initial position to final position. This OG, this line will give you displacement. Of the object. We can say OG, displacement. But here the distance travel, if we have to measure, that will be actual path. Okay, OH plus H. If we are talking about distance, actual path, that will be OH plus H. Always we have to remember the difference between displacement and distance. Displacement can never be more than distance. More than distance. Displacement is a vector quantity. Is a vector quantity. But distance is a scalar quantity. Okay. So we should remember this also. Distance is a scalar quantity. Okay. It is not a vector, so no direction is assigned. But displacement, there is certain direction. In a practical case, maybe we are talking about distance between shortest distance between Delhi and Melbourne. So that is actually we are talking about displacement. We are not talking distance. Okay. So between two towns, between two country capital, whatever we, in the common sense when we are talking, actually we are talking about displacement between two capital of two country. So displacement, the air flight, maybe the aeroplane takes the path of displacement, shortest route. That is shortest route. Displacement is the shortest route between two destinations. Between maybe two places, between two towns, maybe two capitals of two country, two state capitals. So displacement is the shortest path, and we like to follow shortest path. So that is the merit of displacement over distance. That is the merit of displacement over distance. Okay. When we talk about the graphical representation in terms of maybe position vector or whatever, so we can draw in that case also. Okay. So let us talk in the graph how we can measure displacement. See, this is x-axis when we are taking time, y-axis we are taking position. So with respect to time, position of the object, maybe that is very simple. A vehicle is running on the straight path. Okay, and we are measuring the location of the object with respect to time. Then what we see, maybe the position here at t is equal to 0, it was at position x is equal to 0. Maybe x is equal to x1. So position along x-axis, it was moving along x-axis. Now we can show it in the graph. So at time 0, position was at 0. At time t1, position was at x1. Time t2, position was at x2. So 0, here it was, and maybe at time, there are two times. Here it is t1, maybe it is t2. Okay. So how we can measure? How we can put in the graph? That is important. ग्राफ में कैसे डालें? तो ये t1 टाइम पर maybe पोजीशन दिखा रहा है, ये x1 पोजीशन और ये x2 पोजीशन. t1 पर ये पोजीशन x2, ये इनिशियल पोजीशन. Actually, when we are talking about this, could be the initial position. But between time interval t1 and t2, if we have to find displacement between time interval t1 and t2, t1 to t2, then what happens? This is the position maybe A. That is, at time t1, the particle was position. Now, so at t1 time, the particle was at x1. So this is initial position. Okay. Now at time interval t2, at time t2, the particle was at x2. Time t2, particle was at x2. Time t1, particle was at x1. So, according to definition of displacement, the line joining to initial to final position. Okay. So, what is the line joining from A to B? This is the line joining. Initial position to final position between time interval t1 to. So we can say we have to measure this AB. AB is here displacement of the particle. Okay. So AB is here displacement of the. Okay, now this could be given by another way also, in terms of position vector also. Okay, we call it position vector. At point A there could be position vector R1, at B, maybe the position vector could be R2. And then difference in those position vector we can measure. That is final position vector minus initial position vector. Okay. So displacement final position vector minus initial position. Okay, another case maybe in circular motion. How we can find displacement? Okay, maybe this is very straight line motion case, but in circular motion, how we can find? Okay, let us talk about any circular motion, that is in circular path body is moving. Okay, in this circular path, body is supposed to move. The very center of the circular path, the radius is r. The particle at t is equal to 0 was located at point A. And after some time interval, maybe particle is at B point. After some time interval, maybe time t. So here what we see in this time interval 0 to t, how we can find displacement? How to find displacement? So initial, this is initial position. And this is final position. So how to find final position minus initial position? The line joining again. So we will join the line here. This will be. So AB will give the displacement. Of the particle in this case. But here the distance travel, how you can find? This will be the actual path, circumference path. Okay, so displacement when we are talking, it is just equal to diameter of the circular path. Okay, diameter of the circle. That is 2r. But when we talk about distance, then distance is circumference. Okay, distance is the circumference, half circumference here. Okay, distance will be circumference. Actual path is this. So that is a difference. Particle is not moving from here to here directly. It is not going inside. Okay, that is the way displacement we understand. Displacement is not the actual path. Actual path is all about distance path. But it is shortest path. If I am telling you, can we reach from A point to B point in a different way, not actually what the motion is occurring? Okay, we can do it. Shortest, this is the shortest. And that is the way displacement we measure. Shortest path between A and B will be, this is straight line. And this is actually displacement. Okay, this is displacement. That is interesting. But what will be displacement? Distance here. This distance will be here, a, or we can say pi r. Actual path. Okay, actual path travel. Okay, we should consider all this, very important. Okay, actual path, this is actual path. If we are talking about one full revolution, then here again it reaches. Displacement will be 0 because final position is here, initial position was here. So no line joining between final position and initial position. The displacement will be 0. But distance will be not 0. Distance will be one full revolution. Circumference, that is 2 pi r. That will be distance in one full revolution. 2 pi r. Okay. So that is the way we understand about displacement, and that is different from distance. Okay, students? Thank you.